Welcome to Homework Lib.
So over here, we're going to be given a solution which contains 471.6 grams of HCl per liter of solution, and we are told that the solution is going to have a density of 1.329 grams. So before we do the calculations for all of the different representations of concentration, what we're going to do is summarize what we're going to have. We know that the mass of HCl is going to be equal to 471.6 grams. The amount of mole of HCl is going to be equal to the mass of HCl divided by the molecular weight for this compound. In this case, HCl is going to have a molecular mass or molar mass equal to 36.46 grams per mole. So this is going to be 471.6 grams divided by 36.46, which gives us 12.93, well, 12.935 moles of HCl that we're going to have in our solution. We know that the mass of the solution is going to be equal to the volume of the solution times the density. The volume of the solution that we're going to have is 1 liter, and the density is represented in grams per milliliter or gram per cubic centimeter. So over here we need to transform this liter into milliliters before we do our calculation, and what we're going to have is that the mass of the solution is going to be 1,329 grams. Notice that the quantities are going to cancel out, 1 liter with 1 liter, milliliter with milliliter, so 1.329 times this value. So with this, the mass of water that we're going to get would be equal to the mass of the solution minus the mass of HCl. So 1,329 minus 471.6 gives us 857.4 grams. And with this, the amount of mole of water is going to be 857.4 grams divided by the molecular weight of water, which is 18 grams per mole, which is 47.633 moles of water. With this, the total amount of mole is going to be the sum of the mole of water plus the mole of HCl. So 47.633 plus 12.935, which is 60.568 mole. And with this, I think that we have all of the information that we require. So in order to calculate, first of all, the mass percent, this is going to be equal to the mass of the solute divided by the mass of solution times 100. In this case, the mass of the solute is going to be 471.6 grams divided by 1,329 grams times 100 gives us a percent of mass. Let me clarify that this is going to be of solution. Of 35.48%, or up to 3 significant digits, which is approximately 35.5%. This is going to be the first part. Now for B, the mole fraction of HCl that we're going to have in solution, this is going to be the amount of mole of HCl divided by the total amount of mole, which is 12.935 divided by 60.568, which gives us a 0.21 36 mole fraction. Let me separate these guys here. So the mole fraction of HCl would be 0.2136. Next up, we're going to have the molality of the solution. This is going to be equal to mole of HCl divided by kilograms of the solvent. In this case, it would be kilograms of water. The mole of HCl is 12.935, and the kilograms of water are going to correspond to the mass of water, written down in kilograms. So this would be 0.8574 kilograms of water. So the molality of our solution would be 15.086 molal, or mole per kilogram. And finally, the molarity in this solution. The molarity is going to be N, the amount of mole of HCl divided by the volume in liters of the solution. We are told that we have 1 liter of solution. The amount of mole is 12.935 mole. Let me put here mole, and mole. So this is going to be a 12.935 molar solution. And with that, we are done with the problem. So whenever you want to calculate the concentration in different representations, I recommend you to first calculate everything that could be useful to you, meaning the mass of each of the components of the solution, the solute and the solvent, the amount of mole of the solute and the solvent, and with that, you're going to be able to finish your problems. So with that, it would be all. Thank you very much and have a good one.